Hello everyone. Let us now discuss how can we solve this problem, maximum path score in a grid. So the question says that we are given with a m by n grid where each cell contains 0 or 1 or 2. Now we're also given with an integer k. Let us see what are we gonna do. Now we are starting from 0 comma 0 top left corner, and we need to reach bottom right corner, nothing but m minus 1 n minus 1. So by moving only right or down, so we can only move to the right or we can only move to the down. Those are only the two directions which we can move. Now each cell contributes a specific score and incurs an associated cost according to their cell values. If it is 0, then it will add 0 to our score and also cost us 0. Now, if it is 1, the cell value is 1, then 1 will be added to the score and also cost 1. Then, if it is 2, add 2 to your score and it will cost us 1. Now, return the maximum score achievable without exceeding a total cost of k or minus 1 if no valid path exists. If you reach the last cell but the total cost exceeds k, the path is invalid. So, the path should be valid and we get the maximum score. So it is valid only if the cost does not exceed k. Now, from these valid paths, I need the maximum score. So let us look at the constants here. M comma n can be till 200 and k can be 10 power 3, and grid of 0 comma 0 is 0 every time. And as they said, the values can be 0, 1 or 2. Let us take this example and understand it clearly. So I need to reach here and I am at this point. So let us take a path like this. Let us take this path, right, from here and then here and to here. So in this path, let us calculate the score and also the cost. So if it is 0, score will be 0 and cost will also be 0. If it is 1, score will be 1 and cost also 1. If it is 2, score will be 2 and cost also 1. Cost will be 1. Now, what will be the score in this path? So 0 here. Let us calculate the score first. 1, 1, 2 and then 1, 3 and then 2, 5. Now let us calculate the cost here. So every time you get 1 or 2, let's add to that cost. 1, 2, 3, 4. So the cost will be 4 here. Now, instead of this path, let us go with another path. Let us go with another path, right? So let us see what does that path uh, will be, right? So let's go from here to here and then from here to here and then to here. So let's calculate in this path. So this is path number 1, path 1. Let us just assume. Now here in this, the score, what will be the score and what will be the cost? 1, 2, 4, 5, 7. The total score is 7 here. So it is valid, right? The cost will be 1, 2, 3, 4, 5. So let us take the k value as 6, right? So the cost here is not exceeding 6. The cost here is not exceeding 6, right? So it is a valid path. So from these two, I would take the score which is maximum, that is 7, and I will return. I am just assuming that till here 7 will be our maximum score. K is equal to 6. So how can you solve this, right? So we are just going to the end. We are going with every element, right? So let us see how can we solve it, right? First thing is I will start from the score is equal to 0, and also from row and also the column will be 0 comma 0, right? Now first thing, I will be starting with 0 comma 0, nothing but top left corner, and I will return the maximum score or update the maximum score when I get to this end, right? So the first thing is I'm going from here and then here to here and then here and then to here and then to here. So it is nothing but we are going from here to the depth of this, right? So what are the directions which I can go? The directions which I can go is from here, I can go to the next column, nothing but in the same row. So 0, comma 1. Now from this row, I can go to the next row. So for that 1, comma 0. Let's take these. Let us take these directions. Now, if you see, this will be the current row, comma column, right? So what if I write a DFS function? I am writing the DFS function. I am going to the depth, right? So in the DFS function, I'll call with R, comma C and the given grid and also K and the current score and the cost, right? So the first thing is if I meet R is equal to grid dot size minus 1, nothing but this point, this row, or C and also C is equal to grid of 0 dot size minus 1. Then I need to return here itself. But if the cost is less than or equal to K, I will update the maximum score is equal to max of max score, comma current score is S. I am just assuming it as S, right? So that's it. Now how can I call for the DFS function in the DFS function itself? This is void and the max score will be int minimum, right? Now, in this for auto dir in directions, first thing is new x is equal to r plus dir of 0 and new y is equal to c plus dir of 1. The first thing is if the value there, if the value, what will be the value? Value is equal to grid of new x and new y, right? So if first thing, the add cost is 0 and add score will also be 0. If the value is equal to 1, then add cost will be 1 and add score will also be 1. Now, if value is equal to 2, then add cost will be 1 every time, but the score will be changed according to the value, right? So, if this is the case, right? So, I think it's clear for you now. First thing, we'll call for the DFS function here itself. DFS with new x, new y, but do you get something like what if the new x and new y go out of the bounds? So we need to check whether this new x and new y is valid or not. So we will write a is valid function here, right? So if new x and new y is valid, then value is equal to, we'll take it, and then the grid and K. What about the score and cost? So the score will be S plus add score, the score at that cell, right? And the cost will be C plus add cost, right? So we'll call the DFS function here itself, and at the last we will return as it is a void function, right? I think it's clear for you. So, but this won't be running for a longer test cases which will be having till 200, right? It will be going to big O of m into n, even big O of n square, right? So let us see how can you just optimize it or memorize it. So to memorize it, what the thing which we'll be doing is, first thing, let's complete the DFS code here. So the first thing will be calling DFS with 0 comma 0 and with the grid, and the K will be the same and the score and cost are 0. Return if the maximum score is int minimum itself, then return -1. If not, we'll return max score. So in the main function, right? Now, let us go with how can you just memorize it. So here, if you see, I said that there are two cases. The score will be something like 5 from this 1, 1, 1 and then 1, 2, 3 plus 2, 5, and here the score in this path, I think so. In this path, I think so, right? So 2 plus 2 plus 1, 5 plus 2, the score will be 7. Why don't we just take a 3D DP where it stores DP of the row and the column, nothing but the cell, and the cost which it is taking. So here the cost it took was only 1, 2, 3, 4. The cost was only 4, but here the cost was 1, 2 and 3 and then 4. Here also it is 4, I think. Yeah, here also the cost is 4. Now, if the cost is something like, let me tell you, in the same this cell, the cost, let's take another cost. So there will be something like, uh, let me give the indices here. So 0, 1, 2, 3, 0, 1, 2. So dp of 2, 3 and the cost here it is 4. First, it will get 5, and as I got maximum score from this path, I'll just update it to 7. Nothing but the maximum score every time, right? Now, if you see here, dp of cost here, I got 4 itself, but I can also get another things, right? So, what if I just go with from here to here and then 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 here to here? So the total cost here is 1, 2, 3, 4, 5, which is not exceeding k, right? So the total cost is 5, right? Now, what is the score? 1 plus 1, 2 plus 2, 4 plus 1, 5, and then plus 2, 7. So here also we got 7. So that's how the DP works. That's just like memoizing, right? So we just change the code with some of the changes here itself. So first thing, if dp of row, column and the cost is not equal to -1, we'll just return the same dp of row, column and cost. We'll just initialize vector of int dp with everything as -1, and let us see how we just change it, right? So first thing is, if cost is greater than k, we'll just call for this get max score with row, column, grid and the dp and k, which the cost should not exceed, and the int cost, right? So if cost is greater than k, return int minimum. If r is equal to n minus 1 and c is equal to n minus 1, nothing but we just got to the end or the bottom right corner, right? So then we will return 0. Now, if dp of r, c and cost is not equal to -1, that's what I wrote here. So then we will return dp of r, c and cost. So here we just take best. Best is equal to int minimum and new x is equal to r. It's the same thing. But what we do here is we just get the score and make it as sub problem. And if the sub answer is not equal to int minimum, then just update the best and then return dp of rc cost is equal to best. So we'll call with m and then n as rows are m and n are the number of columns and k plus 1. Why? Because the cost cannot exceed k. So k plus 1 comma minus 1 and int result is equal to get max score 0 comma 0, and that's all. Grid and then dpk and then 0. 0 is nothing but the initial cost, and if the result is equal to int minimum, then return minus 1. If not, return result itself. So if you have any doubts, please let me know in the comment section, and I have given the code link in the description. Go and check it. Thanks for watching this video. Please do like, share and subscribe to my channel. Thank you.